another exciting day with my board. All right, so let's take a look at this. Can you guys see this okay? I don't know how to zoom in on there. Okay. How's that? Better? Here was the graph. I want to get through as quickly as possible. Here's the first two. Were you good with this? Graphing it? Everybody can graph it? Use your windows, find and intersect. I don't think you really had to mess with the window that much because it doesn't look very big. Everybody's okay with that? Okay. Here's, which one is this? Here's 3 and 4. So this one has a log on one side. A log on one side said you cannot cancel it, you cannot add a log to the other side. I don't do mine the way they do. I cheat. I don't do it the way they do it. We flip ours to an exponential equation. Base to the exponent equals this. Much, much easier than what they do. They raise this here to the log. They raise it to the log. I don't know why. And then they cancel out the 3's and you set the exponents equal to each other. It makes no sense. A lot of books do it that way, but it's very confusing. Because technically you can raise to the log power, but this is so much easier. This is the way we always teach it here. This one, again, it only has one log. You've got to isolate this first. Get rid of the 7. Then you have to move the 2 up. I would move my 2 up. What if you divide by 2? You can absolutely divide by 2. They divide it by 2. You could do it either way. ln e is 1. If it was ln e this way, but this is to the base, you have to change this to the base. You're going to have to change this to a base e, the same as we do a log. You're going to have to change this to a base 10, 10 to the negative 1. You got to flip it. ln e by itself, ln e is 1.
When it's like that, it's like ln base e.
Big E, not base E. This is a big E. Because then technically it says this. E to the x equals E, and x will equals E, and x is equal to 1. I don't know, something like that. But you can do this, guys, either way. Oh, no, I left my pen. To the negative 1, e to the negative 1 is equal to x squared, or you can do it their way, divided by 2. Again, they raise it here. I wouldn't raise it there. They raise everything to the log power, which is a good way to solve it, but it's a little bit confusing. I don't think any of the teachers here solved it that way.
Yeah,
None of us solved it that way. It's very confusing. They raise this. They kind of swap it around. They raise this. They take the base and raise it to that power, and then so they can raise both sides to either the log or the e. Whatever base you're raising this to, you're going to raise both sides to that power. In other words, you're taking the base, bringing it back down, and raising everything to those powers. So when your bases are the same, then you set your exponents the same. But it's much easier. None of us in this building solve it like that. So either way you want to solve that is fine with me. Divide by 2 or bring it up. That 2 works the same either way. Okay. I made it bigger, so I have to keep moving it over. 5 and 6, let's take a look at 5 and 6. Again, you have a log on one side, so log equals exponent, 2 to the third power. And it will bring you right back down to here. Okay. And solve, check it. You can always plug these back in, check it. Put y1, put y2. See where it intersects, do that. That's an easy way to quick check. This guy over here, you have a couple choices. You can bring this up, or in this case, it's probably much easier to go this way. Get rid of that. So you've got an ln 3x is equal to 2. This is the e power. E squared equals 3x, and just divide by 3. They left it like that rather than here. We do 3 decimals. They probably just do I just lost my train of thought. Exact values. They do exact values, and we do. So I guess I'm not recording. Is that the problem here? I am recording. My board is weird today. 7. Now 7 has logs on both sides. As long as it's one term, you can cancel out your logs. I would just, they raise everything to the base. The base, when it's not there, is 10. So the concept is this, and then they take another step and do this. So we don't do that. We cancel out our logs and we cut right to the chase. So we're here and solve for x. Good? Any questions on these? Because these were good examples. Logs on one side, logs on both sides, and logs all over the place. 7, I think 8 might be here. Okay, here's 8. Again, you have a choice, guys. Let's divide by 2 the way they did. Use your e. E raised to the 3/2 is equal to x. You can just put this in, give me 3 decimals. I just stop there because that's the exact value. ln and e work the same way. They're both logs. The ln just has a natural log. It has a special power, if you will. So number 9. Here's 9. 9's a good one. Which one? Okay. 8, right? You can bring it up instead. You want to bring it up instead, whichever way you like to do this. You're going to end up with the same thing. E to the 3rd is equal to x squared. And then you're just going to take the square root. Watch what happens when you take the square root, guys. When you take the square root of both sides, this becomes e to the 3/2. That's all it is. It's the same difference, whether you do it one way or the other. If you flip this back to a fractional exponent, e raised to the 3rd divided by 2. Either way, that'll get you that one. This one? Which way did you solve it? Did you bring up the 2 or did you divide by 2? Okay, so let's divide by 2. So what if I did this? How would you flip that back to an exponential equation? Because you've got log on one side, so you can't get rid of that log. How would you do that one? 10, right? Raised to the 3/2. Right, and you could just put that in your calc. So I'm going to do the same with this one. So when we didn't have a base there, on the log, it's base 10. On an ln, it's base e. So just put the little e there.
I have the answer. I don't really. Okay.
Oh, okay. You're okay?
Okay.
I noticed you guys have a little bit more trouble with the base e. You must have not really worked too much in base e. But base e works the same way. The problem with base e and the regular logs, if there's no base, you have to put that in. Okay, this is a great one. Logs all over the place. So, first thing you're going to do is condense those. Put a line down your equal sign. You've got to get it to say one term, one term. What were you doing when you subtracted exponents? You were dividing. So this comes down into one log divide statement. Now when you reach this point, you've got one term, you take away the logs. You're never going to have a situation where your bases are different in one equation. They're always going to be the same. When you get to there, now you just got a regular equation, this one. So cross multiply it. Coming down here, you got a factor. Coming down here, you set your factors equal to 0, and then you're going to check. So if I bring a negative 1/3 just into this one alone, this gives me the log of a negative number. My domain says 0 to infinity. So I can't take the log of a negative number. So that one we reject. And then this is your solution. And you can plug that back in and try it. You have that nice change of base thing from the math thing. So that works out nice to check. This is a good one. So we looked at logs on one side, we flipped them, logs on both sides, and logs all over the place. And then number 10. So you can kind of say we really didn't do things very differently than last year. We just did a little bit extra maybe. Again, you got logs all over the place. Before you can do this, bring this guy up here, make it a square. What were you doing when you added exponents? Multiplying. Bring this down to 1 ln right here and multiply it. At this point, take the ln's away. You're right here. Just skip their step right there. They just drop it down to the same base and make them exponentials, but we're fine. Just bring it back down here. You're going to have to resolve this. You got a quadratic, bring everything to one side, and factor. Again, you're going to come back and check. When you pull the 1 into this one, even this one, you get a negative number. You can't take the log of the negative number. So that has to get rejected, and you should say reject. And there's your solution. Questions? Yes. It is. You should have asked me up front if it was up there.
Wait, why did you reject the 1?
Because if you put a 1 in here, 2 times 1 is 2, minus 3 is negative 1. And take the log of a negative number. Okay. All right. Guys, very quickly, let's just walk through this. Logs have special functions. They're inverses of exponents, so everything is reversed. I need you to remember your domain, your range, and your asymptotes, because they swapped around. The point of intersection that we'll go by that's common is on your x-axis, the 1, 0. It used to be the exponent was here. If you struggle, go to an exponential one. This was the 0, 1. Everything has a reflection in the line y equals x. Everything swaps. Okay? My board is like crazy today. All right, again, what transformation is this? What's this one? Horizontal shift left 2 units. And shift left 2 units, and then what does this negative do? Reflection in the x-axis. The y is negating. So with your finger, go from positive to negative. You're reflecting in the x-axis. Okay. Remember, our domain is going to change with the horizontal shift. So if your domain said this, and you shifted over negative 2, your new domain should say this. Another way algebraically to do that, and we talked about this the other day, is to take this, and your domain is supposed to say greater than 0, right? Same thing you do with like underneath the radical, greater than 0. You can just take this and say this has to be greater than 0. So x has to be greater than negative 2. Just use the argument right there and set that greater than 0. Only a horizontal shift is going to affect your domain. It's the opposite of the exponential ones. Just so that you can do that one either way. This one, we have a horizontal shift to the right and then a vertical shift up 4. Can everybody find the intercepts as well? The x-intercepts at the y to 0?
I didn't get this one.
The intercept? Okay, so you're going to set your y equal to 0. You're going to subtract 4. Bless you. Here, let me write this a little bit bigger. I'm going to set my y equal to 0. I got to isolate this guy. So I'm going to subtract 4. I've got logs on one side. I can't take that log away. I can't add a log to the other side. So I'm going to flip this to an exponential equation. The base of my log is 5. Here's my exponent. And I'm equal to this. The rest okay? Add 1 and just stick it in your top. Okay. And again, 3 decimals. What does that negative next to the x do? When x goes from positive to negative, where is the reflection? The y-axis. Okay. This one, horizontal shift left 1 unit. So if I took this and I said, well, it's supposed to be greater than 0, just like underneath your radicals, x has to be greater than -1. So my domain is -1 to infinity. Kind of like when you do the radical thing. If I put it under a fraction, let's say. So that one just had a horizontal shift. The ln's graphed exactly the way the logs graph. If you want to turn this one around to make it look a little bit better, horizontal shift left, 3, and a reflection in the y-axis. On your intercept. After today, you'll do all your intercepts. Regular log here, everybody's okay with that? An exponent, this is your radical. An exponential one is your radical, works the same way as everything else does. Okay, so this gives you, if you bring this out in front, technically just take this and put this out in front. So it's a vertical shrink. It has to be a shrink, right? Because it's less than 1. It's a vertical shrink by a factor of 1/2. Just to kind of go over and make sure you have these. Everybody's good with this? Okay. Alright, so now we should be able to solve everything with logs. Sometimes you don't need to use them, and sometimes you'll be using them. So let's do the first one. Determine when an investment of $1,500 accumulates to a value of $37.50 if the investment earns an interest rate of 8% compounded monthly. We did this exact same problem. This came from your application part 2 when we did the exponents one. So what we did was we did an intersect here to find the time when. When is your time? When is going to be an exponent? So because we didn't do the logs yet, we did the graphing part. Now we'll do it with a log. So let's set up our equation. Remember, you have to know this equation, and you also have to know perks. Those are the two that you're going to have to know, and know the basic formula of these. Okay, so now, let's fill in the parts. 1,500, where does this go? P. 37.50. A. What's my rate? 0.08, 8%, write it as a decimal. What's my N? 12. And again, 12, and there's my time. It's that T that I have to bring down. Now, when we did this before, we did Y1, Y2, and we graphed them. We saw this guy increase, we saw where they intersected, and we found what we needed to find, the time, the when, the x value. Now, we should be able to do this solving with logs because we have a power rule that brings that down. This exponent only belongs to this piece right here. It doesn't belong to this piece. We can cheat. You have two choices. You can take the log of both sides. So if I take the log of both sides, just let's set this up. Leave this like this because you don't want to round this yet. So technically this is the way we should do it. We should take the log of both sides. This is one term over here. Two factors, but one term. So this is a multiply. When you multiplied by bases, what did you do to the exponents? Added them. So technically I have to turn this into an add. And now, where does that 12t go? In front of the first log? The second log, because it only belongs to this guy. So now, to get rid of this one, I have to subtract it from this side. I cannot subtract these values and say the log of 2250. I have to leave it like this. And so then this one would say 12t log. It's a little messy looking, but the process is fine. Now I have to solve for t. So what do I have to do to solve for t? These are all what? Multiplied, right? So what's the opposite of multiply? Divide. So I'm going to divide by the 12 and this log thing. So I'm going to divide by the 12 and this log thing. Now, if you're using the 84s, your alpha key will work fine in here. If you're using the 83s, this needs a parentheses, this needs its own parentheses. So throw that in your calc. Tell me what you get. Yeah, we will, but technically we're not supposed to, but we will. Technically, this is how we should do it. So I'm showing you the right way, and then I'm going to show you the cheating way. This is the way we're supposed to do it. So anybody come up with an answer? Okay, so this is the time in years. If you look back to your exponential equations where we graph these two things, you would get the same answer, right? Now, this is the correct way. We're going to do this again, and we're going to cheat a little bit. We're going to take this side, and we're going to divide, and it's really not cheating because I can divide both sides and isolate that. The problem is this. This one does come down to a terminating number. All is well and good. Sometimes it doesn't come down to a terminating number. If it doesn't, then leave it as a fraction. Don't bring it down to a decimal, to 3 decimal places, because then you lost your rounding. So say this was 1505, and this was 1505, I would just leave the fraction as is. And you don't have to separate a fraction. You would just leave it. This does come down to 2.5. So life is a little simpler. So now I can take the log of both sides here. I'll bring down my 12t. I'll take the log. Now I can divide both sides by 12 times the log of this guy. Okay, and divide both sides by that. All I missed is this step right here. Okay. But my thing is, this one works fine. It terminates when you divide it. If it doesn't terminate, leave the fraction. And don't do anything else with the fraction, just leave the fraction all the way through. So if I had to, this side could say the log of 3750 over 1500 divided by the rest of this mess. The key is you don't want to resolve anything. You don't want to round anything in the interim. You want to round at the very end. So if this didn't round nicely, as messy as it looks, I can leave that there. And I'm not separating this with the divide because this doesn't get separated because this is what we brought back to this. Everybody okay with that? Okay, let's try another one. Let's pick this one. So the population of the town is 123,000, and it is decreasing at a rate of 2.375% each year. Determine when the population will be 50,000. Now, when we did this using exponential equations, we did this. We graphed the population decreasing. We said 50,000. When will that happen? Remember doing this? So now we can set this up. Technically, if you want to, you can go back and just pull off your equations. When you're doing this for homework, if you look back to your exponential, they are the same problem. You don't have to redo the problem. I just can't find mine. So go back and copy the same equation that you found on your exponential. Just solve it with a log. So here's my population. I am decreasing. I'm 123,000. This is my rate. Remember, this is my rate. I am decreasing over time. Okay. And when will I be 50,000? Okay. Now, technically, again, you could take the log of both sides, right? And then you can have a product. You can separate that into an add. If we want to go backwards, just divide by this. This is a good one. All I'm going to do is take out these zeros. Can I take those zeros out? Right? It's like dividing both sides by 1,000. So I'm left with this. I'm just going to leave this. Oops. You can resolve this if you want. You can put that in your calculator and get a 0.9 something or other. But so that you don't make any mistakes, just leave it as it is. Now, take the log of both sides. So I'm going to take the ln of both sides. You okay with that? I brought down my exponent. And to solve for x, I'm just going to divide by this mess. Tell me what you get. How long will it take this population to reach 50,000? I like doing it the other way because I think it looks like nicer than looking at this fraction. This really looks kind of weird looking, but I like doing it the log of both sides and then separating it. But this is a little quicker. The only thing you have to watch, and you guys all have the alpha key, most of you have the alpha keys, they work really, really well in this because you can actually see your grouping. If you have the 83s, you really have to be careful of this. This doesn't need a separate parentheses, and neither does this one on this case because it's both one thing. But on the other one, you definitely had to have the parentheses if you're going to subtract them. So anybody come up with an answer? Say it again. 450. Thank you. So if you went back and checked, you would get this answer as well. So tonight what I advise is when you're going through these, match these up. I kind of wrote where it came from. You had two sets of applications. And so I put the number on there and which application packet it came off of. So see if you can go back and find that. You can absolutely use that equation. No sense reinventing the wheel. Go back and pull up your equation. Instead of using an exponential equation, you're going to use a log equation to solve it. Your answer has to come out the exact same. Okay? So you don't really have too many left to do, right? And you really are not doing the hard part, getting the equation, because you're going to go back and pull that one off. So a little plan today. Let's see if we can come up with a plan.